So we'll just be doing the second part of what we started yesterday with the different similarity theorems. So we did angle yesterday. So we'll just figure out about side angle side and side side, which were both congruence theorems, but they also work for similarity. So for both of these here, instead of showing the sides are congruent, we show that they are proportional. Okay. That's where we make the ratios and proportions and solve for them, right? Now the angles, of course, must be congruent still. That hasn't changed. So sides proportional, angles congruent, and then that proves that they are similar. And this is true for both of these. Now, of course, with side, it's only sides, so we don't have to do the angle part at all. So just with the sides, we just have to show that they're proportional. All right. So if all three corresponding sides are proportional, meaning they have that same ratio, then they're going to be similar. Okay. And this is very close to the definition of similarity that we've already done. So as we're doing this, you're probably going to feel like this is a review. Okay. So let's look at this just in a color-coded way. Okay. Now I'm going to do this as a reflection. So imagine this is like a mirror going down. Okay. So that these two will end up being proportional, and these sides end up being proportional. And recall with side angle side that the angle has to be the included angle. So it's the angle that's between the two sides that you're using. So I can't just pick, if I pick this pink and green lines, B is the only angle that's included with both. So A does not touch the green, E does not touch the pink, so those would not work. It can't just be any angle. It has to be in that particular order, a side, an angle, and a side. Okay, so that's still true here. So if that's, if we have the situation, right, then we know, let's see here, if AB over BC, if that's equal to EB over BD, and the angles are congruent to each other. So this will be, I'll just call this angle 1 and angle 2. And we have angle 1 congruent to angle 2. Then we know the triangles themselves are similar. So triangle ABE is similar to triangle, and the order is important. So A is going to be congruent to C. So we've got to put C first since A is first. And then, of course, B is congruent to B because these are vertical angles. So we expect to have B here for both, which leaves D at the end, which is congruent to E. So remember, this ordering of the letters of the triangle as you're writing your similarity statement is important. Okay. And same thing here with the side. It's just instead of having two sides and an angle, we'll just have all three sides and no angle. So we'll have, once again, AB to DE. And we'll have, go all the way around, BC to EF. Okay, but here we have a third side instead of an angle, AC to DF. So if you have all three sides have the same exact ratio, then the triangles are congruent. So triangle ABC is similar to DEF. Now these are both alphabetical. That's just by chance, doesn't have to be that way. Remember, the first two here, AB, should be congruent to DE. So the first two letters should be AB and DE. Okay. So make sure we just do that always in the right order as we're going through this. Thank you. Yeah. If they're the same ratio. Yeah. So as we're doing these, you can see that pretty quickly if you're going to do side angle side or side side side. Like, so if they have an included angle like they do here, right? Angle X and angle A here are clearly equal to one another, right? Because they both say 65. So it's a good hint we're trying to use side angle side. As long as the two sides are connected to the angle, we're in good shape. So AB over XY would be 8 over 4, right? And we're trying to establish, question mark, if it's equal to AC over XZ. So that's 18 over 9. Okay. And if they come out to the same number, then we can say, yes, they're similar. So clearly 8 divided by 4 and 18 divided by 9 are both equal to 2. So they are the same. And then as the directions say, if write a similarity statement. So that's the triangle statement. So ABC, similar to triangle XYZ. Just like that. So that's a side angle side. Then we have a side side side. So we have all three sides. Pretty clear we have to use just that. And there's no angles marked here, so you have no option. Now, theoretically, if this was marked, let's say these were marked as right angles, you would have an option. You could do side, 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 or side, angle, side, right? But without that there, we have to do side, side, side. So same idea. What I did with the two colors here, we just go one more round and do all three. So here I'll do is 15 over 24. Same as 20 over 32. And then we got this third side now. The same as 25 over 40. Now you can just reduce these fractions or just use calculator, punch it in. So punch in 15 divided by 24, 20 divided by 32, 25 divided by 40, and see if you get the same number. The number's not too important. Technically, it'd be like a scale factor if we're doing that K value, but we're not. So what's important is that they're the same number or not the same number. If one of them is different, then it's not similar. So 15 divided by 24, 0.625. And then 20 divided by 32, and 0.625. And then last one is also 0.625. So it checks out, they are similar. Now you'll notice here I did on number one, I did the left triangle on top, the right triangle on the bottom. Number two, I did the right triangle on the top and the left triangle on the bottom. Again, it does not matter. Someone else could have done it 24 over 15, 32 over 20, and 40 over 25. They would still be getting the same number on all of them. It'd be a different number, but that's okay. Okay? It just kind of difference between is this an enlargement or is it shrinking? Okay. Yeah, it's the fact that they're consistent is what's important, not what the number is itself. Okay. And then we have, we got to write the statement here. So it doesn't matter really where you start. I'll go ONM. Triangle ONN is similar to. And if you happen to be using your highlighter as you're doing these, it'd be a lot easier to write these accurately because you'll go to O and you see two different colors, so you know that's going to be congruent to the same two colors in the other one. Now, when they're in the same orientation like they are right now, it's not too difficult to figure out. It's when one's rotated, like number 4, or going down to the bottom of the page when you see they're not the same orientation. You got to be a little more careful. And it's a small detail, but it is where most of the mistakes happen. So it's worth mentioning. Okay, one more on this row. So you can look at this, 36 over 24. You can see I'm doing the left triangle over the right triangle, back to how I started. And then I'll do left 20 over 18. Okay. And just double check to see if those are similar or not. Similar by being the same. 36 divided by 24 is 1.5, 1.5, right? Okay. And 20 divided by 18 is 1.1 repeating. So these are not the same, so we'd say not similar. Of course, if they're not similar, we're not going to write a similarity statement. We're not going to write one of these, right? Yep. So don't forget, as you're doing this, it could go either way. Let's see here. Down here, to mark very carefully, you can see there's a congruent angle right here. So we're going to be using the side angle sides. I'm first going to color code what I'm going to compare. So those two. And I can do small over, I can go either way. I'll do the big triangle over the small this time. I'll do 6 over 4. And is that the same as this big length? What is this whole length from M to Q? So from here to here is 8. Here to here is 4. So the entire length is 12. So we got to be careful there. Right? And this length right here, just for the small triangle, is 8. Yeah, so 8 and the 4, that's how we knew this entire length was 12. So it's not always the same as the easy ones above on 1, 2, and 3, where you just have to take the exact number that you're looking at and put that in the ratio. Sometimes we got to add or subtract some numbers to get it right. All right, so check that. What do we get when you punch in 6 divided by 4? 1.5, and 12 divided by 8? 1.5. Yeah, so these are similar. Write the statement. Triangle. Let's see here. I did the, let's go MRQ. Is similar to triangle. And what's congruent to M in the little triangle? M again. What's congruent to R in the little triangle? N. And then last would be P. There we go. Okay, so as another side, angle side. So when we have 2 here, and on numbers 5, we're back to like number 2. You can see we got 3 sides, no angles congruent. So we're going to do something like this and just show all 3. But nothing new here, just a little more practice. If you want to try it on your own and see how you do, that's fine. Doesn't matter if you do it like mine or if you flip them. Doesn't matter the order at all. Which one I'm writing first or second or third, that does not matter either. Only thing that matters is that you're using corresponding sides carefully. 15 over 10. All right. Once again, 12 divided by 8. $1.5. 6 divided by 4, 1.5, and 15 divided by 10 is 1.5. If you did the small over large, you got 0.6 repeating, 0.6 repeating over and over. Doesn't matter if you got 0.6 repeating for all three or 1.5 for all three, they match. So that's the whole idea. I'm going to say M, N, L. Similar to, what's similar to M? Okay, where my pink and green come together. So we'll have right here, which is H, and N, pink and red. So that's going to be J right here, which leaves G at the end. There you go. And of course, there's many correct ways of writing this. You can write these letters in any order. Generally, you like to do an alphabetical. I didn't here. So L, M, N would probably be more universally accepted, but it's not wrong. It's just writing it a non-popular way. Okay, so one more, just with the embedded shapes that are overlapped. Okay, so just be careful on here. You want to find one set of corresponding sides that you have numbers for variables. So I'm going to use these two. So I got my small triangle here. Now for the red, the length is 16. What is the length of the green? Yeah, 24. So like the other example above, you can't just take 8, because that wouldn't be the length of the whole triangle. That'd just be the length from here to here, which is not a triangle at all. That'd be like a quadrilateral of some sort. So the triangle side, the whole length is 24. Okay. And we have two variables, which means we have two separate equations. So I'll do one equation with the x in it, one equation with the y in it. Let's do the x first. All right, so I'm doing small over the big triangle, right? So small triangle would just be a length of x. And this entire side right here, what is its length? Yeah, kind of like we did 8 plus 16. This entire length from here to here is x plus 9 or 9 plus x. So we'll use that in here. And from there, we know how to solve by cross multiplying. So just 24x equals, now put the x plus 9 in parentheses. So it'll be 16 times x, 16x. 16 times 9, which is 144. Okay. And then go and solve that. Subtract 16 on both sides. We'll have 8 times what is 144. And divide both sides by 8. And we'll have, see here, 1, 8. Okay. And lastly, over here for y, a little bit easier. Again, small triangle on top. So I'm going to do, here's the length of that small triangle, 7.2. And over here, the length is just y. So we don't need to add or subtract anything on this one. A little more straightforward. And then same as before, 16y equals 24 times 7.2, which is 172.8. Yep, that makes sense. And then divide by 16 on both sides, so y equals 11, 10, 10.8. Okay, perfect. And we can somewhat verify these answers. If this is 7.2, we expect y to be a little bit bigger than 7.2, so the fact that that came out to 10.8 is reasonable. If I got an answer of 100 something, I'd wondering what's wrong with my math and go back and find the mistake. Same thing here. This has a length, the small triangle has a length of 16, so I expect when I find x to be, maybe a little bit bigger than 16, not smaller for sure, because it does appear to be longer, but not way too big. Like it can't be 30 or anything if this is 16. This is a little bit bigger. So the fact that this came out to be 18 is a good sign that we're in a good place. I mentioned this because you'd be surprised how often when I'm grading quizzes and tests and people come up with these enormous answers and then turn their quiz in with 10 minutes left and say, well, I'm done. I wrote something. And clearly there's no way that's the right answer, but they just say, well, that's what I got, because there's no way to know for sure, so why even try? When really you can, somewhat verify. Like y could not be less than 7. If you got an answer of 4, this is clearly bigger than this, so it has to be bigger, right? That kind of stuff can help you estimate your answers. Okay, on the back, you have some problems to do in the similar way. Won't take you too long. Just realize there are not similar, so don't just assume everything's similar. We want to verify angles are congruent and all that stuff first. We got some with algebra down here. Got the x's and the y's. Here's like a problem we just did. We have an x and a y, two different proportions needed. Here's with some algebra, so you have to distribute. Just remember when you're doing this, you put these in parentheses so you actually distribute to each value inside. Same thing here. You'll be distributing here. Okay. And down here, just a little review. Just find that k value. Recall that if you're going like on this one from a smaller shape to a bigger shape, the k value should come out to be bigger than 1. And then we go to something like 13, where you're going from a bigger shape, DEF, to ABC. It should be a k value that's between 0 and 1, okay, something less than 1. All right, so that's it. You got the rest of the period to get that done. Recall, I will not be here tomorrow. You'll just have a review. All the math teachers are in meetings tomorrow. I won't be here, so you'll just have a review. I think we'll do even a little bit more review on Thursday and just quiz on Friday and wrap up the week that way. Okay, so I'll do 2 days of review just so we don't have to start something new on Friday. All right, you guys got the rest of the period to get this done.